So today we have a hard problem and I didn't solve it. Now let's look at the problem. We're given a string with numbers 0 or 1 and an integer k. We must flip exactly k bits at step. So it became 1, 0, 1. And they ask us to find the fastest way or shortest or smallest number of steps to make it exactly all ones, and if it's possible to return -1. So this is a problem, and let's look at my failed attempts to solve it. I give myself 30 minutes to try it myself, and after that I gave up. Now immediately I spot some things about this problem. We can choose any particular numbers, so the problem can be compressed just to count zeros and ones and k. So we have three numbers like 3, 5, 3, like this, and this is a problem. Okay, what can we do with this kind of intuition? Given that we have only n possible zeros plus ones, that means the entire space of the solution is from 0 zeros to n zeros, n minus ones zeros. This is how many zeros we can have. Oh, I think I had a mistake. This is n is the maximum number of zeros we can have. So this is a space, and the space is 10 to the power of 5. So it's still big. However, we now have a finite space, and now let's look at the number of zeros is our state. What can we do with the state? And we have k that can be flipped. So we can flip exactly. So imagine we have situations where k is bigger than zeros. We can flip entire zeros to become ones, and ones should become zeros. The other situation is that k is less than zeros. So we have to flip entire zeros, be converted to ones. Oh, sorry. This is zeros, and the green is k. And the third situation is when we have exactly match between zeros and k. And then we flip this, and doesn't matter what kind of how many ones we have, we just convert it all into ones. This is our final state. So that means we have some transitions from the current state is number of zeros, and we can go to some different other states. So we can convert just one single zero, convert 2 zeros, convert 3 zeros, and so on. And this was my intuition, and I wrote this kind of ugly code with duplicated for loops with almost the same logic. This is a breadth first search, and I tried to search in this graph of states if any can reach 0 state, the final 0 state. So this is the shortest path. However, I notice that my code doesn't exactly work. Some corner cases, and finally I spot the state that has some repeats, I called it. So this was wrong. So you can't just take any zeros and put it into a visited set. Now let's look at a solution that actually works but have time limited exceeded exception. This is exactly the same idea, but for the take zeros we consider maximum and minimum value we can take. So take zeros. This isn't one step of the depth first search. Is lower and upper bound of how many take zeros we can have. The upper bound is that we can take k or current zeros and minimum value of it. So this is how much we can take at most. At most k or r or zeros is our upper bound. And for the lower bound you have to consider how many ones you have. So 0 or k minus 1 ones. This is a lower bound, and this is a maximum. And this solution worked fine. So it's same idea, visited set. So my initial code was almost correct, but it's kind of off by one type of error that I should be more careful with this one. I should spend more time to reason about how many zeros I can take. So, and this is a work and fixed solution. However, it still hasn't accepted because time limited exceeded, and this for loop from the lower bound to upper bound of taking zeros can be O of n, and steps 10 to the power of 5, and steps also can be O of n by the graph theory, because the shortest path between all the nodes in a graph is almost the number of vertices plus 1. So let's look at what intuition we have to take the accepted solution. I didn't solve it myself. I looked at other people code, and I can't understand it because this many words, but I just feel lazy to read it and understand. So I consulted the Gemini, and he found this nice little solution. I would explain what I understand from it. So this is not my intuition. Now I'll try to explain what I understood. So looking at TLE solution, time limit exceed solution, we should optimize this inner for loop of the breadth-first search. And this for loop is just considers every possible zero state transition we can make from the corner to the next. Now let's deep dive into this transition. So imagine we have some number of zeros, some k, and let's find some other properties that I didn't discover myself, but I found it from the other people. Now the property, first property is that if we have, imagine number 5 is zeros, k is 3. What other states we can have? So we can take all k zeros, so it's 5 minus 3. Then we can have 5 minus 2 and 1 would be converted, like 2 we have and plus 1, because 1 we converted to 0. So 5 minus 3 is 2. This is 4. The next is 5 minus 3 plus 2. 2 is from ones. 2 ones we converted because, oh, I'm apologize, this is not correct. So this is 1. This is k. We just split it between converting ones and zeros. And the value is 4 plus 2 is 6. And the final is 5 minus 0 plus 3 from ones. And this is 8. So we only can jump to these states. What does it mean? What does it mean? So it's some kind of sequence: 2, 4, 6, 8. It's all odd or even numbers. All even numbers. And it's the finite sequence, like exactly from 2 and exactly to the 8. So this is left and this is right sides of this range. So we can say that our jump from 5 is exactly left right range expansion. Now okay, this is one intuition or insight that we have. We preserved this even order, and we have this finite consequential numbers. Even so, they have gaps between them, but they are like exactly one number. Now, what can we learn from this? So, in the binaries breadth-first search, we iterating over this range, and this range also continuous range, and that means take zeros is this is exactly this range. It would be 2, 4, 6, 8, these numbers, if z equal 5. So this is for loop, and that means we just found that we can actually instead of using this for loop, we know that this is just a range, single pair of numbers, left and right. Okay, that's kind of points out to some insight. Next should be happen, but it still doesn't obvious why and how we can use it. Okay, now let's again look at the final code. And this is not, this doesn't use QA at all for the breadth-first search. This is kind of interesting. Instead of using QA, it uses this left and right pointers, exactly what we think about. And if we put all these left and right pointers to the next step of the QA, we know that each value should give us some left right pointers, new left right, and this is kind of continuous range, and that means we can skip the QA. Now, how can we find this new left and right, and what exactly numbers for the left and right we want to pick? This is a second step of this kind of intuition, and by looking at this code, so the left pointer, the target is target. Let's think about target. The target is 0. So 0 zeros. That means we want, before the target, we want k, and k is our new like left pointer, and the second target is all n zeros. Oh, I'm sorry, this is n minus k. To convert in a single step to all ones. And this kind of tricky intuition about how you choosing this lowest left and the biggest right. That means if k in left to the right, if k in this range, k in left right that means can take, so this is a 2, 4, 6, 8 numbers, left 2, right is 8, and if k is, for example, 3, then what can we do from this? The 2 is state, 2 is number of zeros. So if we have 2, k 3, we take all 2, became 0, plus 1, 1, and this is 1, right? So if we have 4, we take all 3, convert to ones, and still we have 1. If we have 6, we convert 3 again. Yep. If we have 8, we convert again 3. So I'm kind of not fully grasp this intuition, I think. So the logic is we gravitate towards 0, and this means 0, and this means again 2, this means again 1 in 3 steps. So in one step we are trying to reach 0, and if we in the left-right situation, then we can expand L to 1. This would be the next step. So this 6 is kind of not obvious why this 0. L plus k is the parity. So if k equal 2, this should be all like 0, 2, 4, and 6. So the parity is saved. Should be saved at least. So it is 1, 1, 3, and 5. And this kind of, if it's if left pointer plus k, so left is 2, k is 3, is 5, and we reached 1. If left pointer is 2 and k is 4, then it is 6, and we reached 0, because we're doing this %2 operation. Now I kind of not very clear why we shortcut this fast. Like if this is 6, it doesn't mean we have to jump 2 times, but we're doing it in a single step. Maybe I don't clearly understand why it is so. Anyway, this is not my solution, it's okay. So the new right is the same, but the target is length minus k, and the logic is the same. And this is just we trying to reach the left as soon as possible, and this is trying to reach the right as soon as possible. So minimizing this as length minus some minimized value. So also by looking at the graph intuition, we can ditch the visited set. It doesn't matter because we have exactly 4 loop in S-length steps. Okay, it I kind of didn't explain it very well. Okay, that's alright. That's fine. That's it for today.